Our friends at the Beyond Earth Institute are hosting their annual symposium in Washington, D.C. on November 1st and 2nd. The theme this year is Leo to Lunar to Living Beyond Earth. You can join senior leaders from across industry, government, and the international community to examine the policy challenges impacting the rapidly evolving space ecosystem. Leaders like Michelle Hanlon, Lieutenant General John Shaw, Frank White, and more. Register for the event at beyondearthsymposium.org or space.n2k.com/beyondearth. We hope to see you there. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazis, host of the T-Minus Space Daily podcast. Deep Space includes extended interviews and bonus content for a deeper look into some of the topics that we cover on our daily program. And if you're listening to this on the day we publish, then it is October the 14th, 2023. And today, an annular solar eclipse will cross parts of North, Central, and South America. Now, this eclipse will be visible for millions of people. And if you're one of them, this episode will help you understand what you'll be seeing and how to do it safely. And if you're not in the path of the eclipse, and same, it's still good to know what causes an annular eclipse and how it differs from a total eclipse. Because chances are you will experience one at some point in your life, after all. So I spoke to Dr. Chaz Miller from New Mexico State University's Astronomy Department to tell us what we need to know about annular eclipses, as well as today's eclipse in particular.
Hello, my name is Chaz Miller. I am an engineer and astronomer, currently working at New Mexico State University. I'm here today to talk about eclipses.
Thank you so much, Chaz. I'm delighted to speak with you, and it's a very timely conversation. As some of our audience probably know, although maybe not all, we are expecting an eclipse of some kind on Saturday, October 14th, and it's one of those asterisks. Not everyone's going to see it. It's going to depend on where you are. So let's get into that a little bit. What are we expecting on the 14th?
On the 14th, we're going to see a solar eclipse. So that is when the moon passes between the Earth and the sun, so blocks out part or all of the sun. So the upcoming eclipse is called an annular eclipse. And so I could talk a little bit about what that word means. It doesn't mean yearly. In fact, solar eclipses can occur as often as twice a year. They don't happen every month. They can happen as common as twice a year. But as you mentioned, they don't happen everywhere on the Earth. The shadow of the moon is actually quite small when it reaches the Earth. So there is a limited area on the Earth where you can see a given solar eclipse. Of course, it has to be daytime during the time that the eclipse is occurring for you to be able to see it. So half the Earth couldn't possibly see it. But even on the side that
makes a
can
lot
see
of
the
sense.
sun, yeah. But the side that can see the sun, not everyone will see it because the moon won't line up exactly from where they are. So when you have a particular solar eclipse, you can go online and look at maps, and they'll show you, looks like little strips that go across the Earth. And that's actually the path of how the shadow will pass on the Earth during that particular eclipse. So you need to be somewhere in that region if you want to be able to see something interesting.
Who's going to be able to see the one on the 14th? Because I'm in the Northeast. I know I'm not going to be able to see it, but who's going to be able to see this one?
So this is going to be mainly something that people can see in the Western United States. If you want to see the full eclipse, which we'll talk about what that means in a minute, I'm looking at a map right now, and that'll pass through Oregon, Nevada, Utah, New Mexico, Texas, and then off into the Gulf of New Mexico. People to the sides, there's sort of a strip there, and that's where we'll talk about this ring of fire. But if you're not in that path, you can still see the moon passing in front of the sun, off to the side a little bit. It won't be passing directly through the middle of the sun from your viewpoint, but you'll still see a chunk of the sun being taken out over time and see something else. But all the way out on the East Coast, you'll still be able to see maybe something. So it depends on where you are on the East Coast. You'll be able to see a little bit of the edge of the sun get eclipsed during the time there. So you can still do that with proper eye viewing, I must say first. You make sure that you have proper eye protection. You'll be able to look at that even as far out as the East Coast if you want to.
Indeed. Please do not look directly at the sun, in case you didn't know that. And also, I have this little warning picture that nobody can see because this is an audio podcast. But my favorite little thing that comes with telescopes is please do not point your telescope at the sun.
Right. Yeah. As anyone who knows who's ever taken a magnifying glass and burned things using the sun, imagine doing that to your eye. You would never want to do that. So there are filters you can buy or there can be purchased that can filter the sun to look at through things. But most times people don't have those, and telescopes don't usually come with them. Find a group, an astronomy group that may have those. Search those out on the internet locally, and you could then use their equipment because they know what they were doing. They use it properly. It's safe. But don't anyone else do that because that's even worse than staring at the sun with your own eye.
Yeah, I mean, I'm laughing at it, and I appreciated the disclaimer my telescope came with for all of us who have like a little one at home to look at the moon with. Definitely do not point that at the sun. All right, so we've given the obligatory disclaimer of please don't fry your eyeballs. So let's get into the different types of eclipses. So I always feel funny saying annual versus annular because to me, I live in the Boston area, so I always feel like the Boston's coming out annula, and but it's not.
It sounds like that.
They are two different things.
Right.
It does a little bit, and then there's also a partial total. All that. So yeah, please walk me through it.
So actually, annular is a type of partial eclipse. A partial eclipse means that the entire bright surface of the sun, that the blinding part, is not going to be totally covered. So there's a total eclipse we'll talk about later, and there'll be an interesting example of that in next spring. This will not be that. So there will always, for everybody who can see the sun, even in the middle path, see the eclipse, you will be able to still see part of the bright part of the sun, which means you must have eye protection at all times. But if you are in the central path, the moon is going to pass directly in front of the sun, but it won't be big enough because it's in its part of its orbit where it's a little bit farther from the Earth than average. So it looks a little bit smaller in the sky. It won't cover the whole disk of the sun. And you'll see a little ring of the sun still, even when the moon's directly in front of it. That ring is the shape of an annulus. So that's therefore an annular eclipse. And that's where that term comes from. And the fancy term is ring of fire, but it's simply the sun that you can still see if you look at the eclipse during the middle part and the moon is right in front of it.
We'll be right back.
Hit play and feel the real with Bose Quiet Comfort Ultra earbuds. Breakthrough immersive audio makes all your music feel more natural than ever by taking it out of your head and placing it just in front of you. Like listening without wearing earbuds at all. High-fidelity audio and world-class noise cancellation are tailored to your ears only. So everything's personalized and hits just as it should. Bose Quiet Comfort Ultra earbuds. Dive in deeper at bose.com/Spotify.
For our friends who are not up on their Latin, an annulus is a ring. So I had to Google that real quick because I was like, I'm pretty sure it just means ring, but let me just double check that. Okay. So if I understand correctly, you have done some eclipse chasing in your life.
A little bit. Actually, the very first, I've seen lots of partial eclipses, because again, you can see them from far away. I've seen an annular eclipse before, ironically, in Albuquerque. The very first one I ever saw was in 2012. It happened to directly pass over Albuquerque, and weirdly enough, this one will too. So Albuquerque got lucky in a way. That happens to be sort of in the central path of two different annular eclipses so close together. That's an unusual thing to happen. The very first total eclipse I ever saw, I did travel, like a lot of people did in the United States in 2017, to see the path of that total eclipse. And so I caught that in Nebraska. And then more recently, a friend of mine who had graduated from grad school with me invited my family to go join him in Australia. We traveled out there to see the latest total solar eclipse, which was only viewable in a tiny little section of Australia. And so we traveled there in April and saw the total eclipse there as well. So there's people who do this all the time, and they've seen them everywhere on the Earth. So that's my minor history of chasing. But then I hope to keep doing that next April when there's another one. Not here in New Mexico, but close enough for me to go take a look at it.
Yeah, I'm hoping I can see that one. It's in April, and I'm in the Northeast, so I figure it's going to be cloudy chances are I'm not going to be able to see
Well,
it.
yeah.
But
That's always
crossed.
the other issue too. Yeah, you can never. Yeah, you're always there. It's always, but you have to hope that doesn't happen. Yeah, the path of the total eclipse will pass, through Ohio, out east, through like Erie, Pennsylvania, northern New York. So if you're anywhere close to there, you could drive out to those locations if you have time and see if you can actually get in the path of the total eclipse.
Keep an eye on radar, see if there's going to be cloud cover that day, maybe. But I'm curious because I've only seen a partial eclipse in my life, and that was the 2017 one when I was up here. It was partial. I remember the weird shadows on the ground, but I have only heard anecdotes of what it's like to see a total eclipse of any kind, and I'm just really curious what it's like to experience that, like what you see.
Yeah, I've seen the annular, and that was before I ever saw a total eclipse. And like I say, the whole sun doesn't get covered. Like over 90% does. So you think, well, it must get really dark. And it surprisingly doesn't. If you're looking around, it's still very daylight, but it's a weird light even then. Like you said, it's kind of like a partial, but a very deep partial eclipse, where it almost seems like it's overcast, but you don't see any clouds. So it's like an eerie kind of light, but it's still pretty bright. But at a total, right at the very last minute or so, when those last parts of the bright part of the sun are getting covered, the light changes pretty rapidly, and it starts to go from that, what we saw in the annular, to darkness. So when you finally have the moon totally covering the disk of the sun, the sky above you is dark, and you can see a few stars, at least Venus, a couple of planets. It's not totally black where you are. It's not like nighttime. It's really weird because you can see on the horizon light, because what you are in at that moment is a tube of shadow, which is moving across the earth, and it happens to be passing over you at that time. So all around you, miles and miles away, they're still in daylight, and you can see a ring of light. It almost looks like sunset all around you at that moment. So, but it's an odd feeling because then it's dark, and what you see in the sky, you can look at with your own eye. You don't need eye protection at that time. You can see the corona of the sun. That's a part of the sun you can't see because the sky's too bright and drowns it all out. But you can, at that time, see this weird glowy aura with a black disk in the middle of it, just floating in the sky. It's a really odd sight and really cool. And you only get a few minutes to look at it before you have to put your eye protection back on. But the feeling is the same. And I've heard people say, like, it gets really cold. It does feel a little cooler, especially if you're in a place where the sun's beating down on you. Those last minute, you can actually tell that it gets a little bit chillier. It seems like the birds get quiet or something. That might be just a feeling. If I was sort of with people, you try to just get quiet. You just look at it like, ooh, that's weird. And they don't know what to do except to stare at it, which is really cool. So there's sort of this little hush, at least where I was, where that happens because everyone's just staring at the sky.
Yeah, it's sort of nice in an almost wholesome way that stuff can still impress us nowadays. That even when we know exactly what it is, it's like it can make us all go, "Oh wow," which is like that's nice. And you
I thought the same thing. I thought, well, I've seen it all, and I don't study the sun. That's not my particular focus of study. But I went to many, many talks of people showing images from spacecraft and telescopes and like super magnification of the sun, all kinds of cool things. And I thought, oh, I've seen all that. I'll be ready for it. And then when I saw the total eclipse, it's like, oh my gosh, that's amazing. And that's all I could think of. I had no other scientific, just looked at it and said, wow, I'm looking at something weird in the sky that I didn't expect. I could really see if people didn't understand that long ago, how that would inspire, fear. Because something really weird is happening that doesn't look anything like a partial eclipse at all.
Yeah, I was just thinking the same thing. Like if you didn't know what was going on, that would be absolutely terrifying. So it's kind of, it almost makes you feel connected to humans back when in a moment, I would imagine. That's such a cool experience that I really hope I will have one day. But in the meantime, Chaz, it's been a delight speaking with you. Thank you so much for all this great information on the eclipse that I hope many of our listeners will get to see in person on Saturday, and if not, maybe the total eclipse that will be happening next year, fingers crossed. And of course, there will always be more eclipses. So if not these two, then something else. So thank you so much for speaking with me today. I really appreciate it.
Well, thank you for having me.
That's it for T-Minus Deep Space for October 14th, 2023. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazis. Thanks for listening.